it work? The area of a parallelogram, base times height. So the tough part about parallelogram is that it encompasses 5 different shapes. Parallelogram are 4. A rectangle, a rhombus, and a square. So all of those shapes are parallelograms. Let's go with an easy one. A just traditional parallelogram. Do you have enough information to find the area of that parallelogram? No. Awkward. You need a height. And a height is always the distance between bases, aka an altitude. So you always need that number. So generally I'll give that number to you. So now what's the area of that parallelogram? 8 units squared. What's the other height?
Question mark. 4.
What is the height between those bases?
Well, you would have to make it work.
Okay, what's the area? 8. What's the base? 3. The height is x. So you can forward solve for an area, then you can backward solve for another height. So the other height would be 8/3, aka 2.66. Okay, that's about the complexity of what we're doing for those. And then triangles is 1/2 base times height. Okay, your height is always the distance or the altitude of the corresponding side. So find the area of this parallelogram and find the other height. So what 2 numbers do you have to use now to find the area of this parallelogram? So the area of this parallelogram is 7 times 9, aka the area of this parallelogram is 63 feet squared. Okay. You have to use this base and its corresponding height. It's always the distance between bases. Now, if I asked you to find this height, could you do that?
Yeah.
Now, the area is equal to the base times the height. What is the other height? 7.875. They're kind of, how do you feel about that? This is the only difference between a regular class and a pre-AP class. And the regular class is just find the area. In the pre-AP class, we're asking you guys to solve for the other height. So you have both heights of the parallelogram. So in one way, you're doing area equals base times height, and you have the base and you have the height. In the other scenario, you're missing the height, and that's what we're asking you guys to solve for. Solving it forwards, getting an area, using the area to solve backwards to find the other height. Everybody good? Yeah. Aaron, you good? What about this one? Area equals, what base are we using?
3.5
times which height?
12.
36 plus 6 is 42. So the area of that parallelogram is 42. Using that information, what is the area? What is the other height? So if the area is 42 millimeters squared, and we're using this base, what is the other height?
Oh.
42 divided by 13. 3.23. Easy? Feel good? How else can I make this more difficult?
By not giving us numbers.
By not giving you numbers. Use a ruler. Same thing there. Alright, so triangles now. So second layer. There was one shape. Is there any questions about parallelograms and how to use base times height? So now with triangles, there's two different versions we can use. The area of a triangle is equal to 1/2 base times height, or the area of a triangle is equal to base times height divided by 2. It's kind of like whatever you want. They mean the exact same thing. Then that kind of wraps up the extent of the new formulas that we're using today. So you kind of pick a layer and stick with it. Which one do y'all want to use, top or bottom? The bottom one? I don't care. The bottom one. Let's use the bottom one because you guys like that one better. So, the base can be any side of a triangle. Any side can be the base, but the height is always the length of the corresponding altitude. So the height is always the length from the base that you're using to the opposite vertex. So it says the triangle has a height of 5 and a base of 8. Find its area. Base times height
Oh, so 40,
divided by 2.
20.
No.
20 centimeters squared.
20 centimeters squared. Because 5 times 8 is 40, and 40 divided by 2 is 20. Because it's an area, it's in square centimeters. Yeah? Okay, now a triangle has an area of 24 square centimeters. It has a base of 8. Find its corresponding height. So just to see what happens, the area is 24. The base is 8. So to get rid of that 2 on the denominator, you multiply both sides by 2. And then divide both sides by 8.
Oh,
6 meters. 6 meters.
It's just 6 meters because it is a one-dimensional length,
On here.
it's not an area.
so
Groundbreaking stuff, guys. Yeah, I feel like I've probably learned this before.
oh, definitely.
Definitely. Once or twice. Let's talk about this one. Easier or more difficult? Huh?
It's like the same thing.
It's the exact same thing. The only difference is I actually drew you a picture. So the area of this triangle is base times height divided by 2. Or 90.
Yeah,
Do you believe me?
sure.
How did I do that in my head?
Because you went to college.
No. It's 12 divided by 2. 6 times 15. 90. God.
But you didn't divide. What? Hold on. Get it again.
Multiplication is commutative, so you can do it any order you want. 6 divided by 2, or 12 divided by 2 is 6.
6.
And then 6 times 15 is 90.
But you.
Or 12 times 15 is 180. 180 divided by 2 is 90. Or 15 divided by 2 is 7.5. And 7.5 times 12 is 90. Kind of like the grade you got on your test.
Ouch.
I don't know, just making stuff up.
That's all.
Okay, let's get to the. Ooh. So here's your first introduction to a composite figure. A what? A composite figure, which is composed of two different figures. That's why, aka composite figure. But is it really a composite figure?
No. Just add the thing together.
So how long is the base?
16 inches.
Inches. How long is the height?
7 inches.
So using this base and its corresponding height, you can solve for the area of that triangle.
Eight times 7, 56.
Good job.
Squared.
56 square inches.
Imagine that.
Now, if you wanted to nerd out, you could find the corresponding height for each other side. Because I have an area, I could solve. Oh, I don't know how, it maybe looks like this. For that height.
Stop it. Sorry.
Because there is a height that goes from each base to each vertex that is perpendicular. So the area of the shape is still equal to base times height divided by 2. I have an area of 56. I have a base of 9.2. I have a height of h. So I could solve for the other altitude if I wanted to. Multiply both sides by 2. And then do 112 divided by 9.2. So the other height would be 12.17. So you can still solve forwards and then go back and solve backwards. Just fun stuff. No. Okay, here's your for real first composite figure. How about this one? It says you have a parallelogram and a triangle. What is the area of the figure?
Oh. 18 times, or 18 meters times 50 meters over 2 to find the area of the triangle.
Okay, so you can work with the triangle first. The triangle has a base of 50 times a height of 18.
I can't.
Yes, you can. What's 9 times 50?
I have no clue. 450 off.
9 times 5 is 45 with an extra 0 is 450. So the area of this triangle is 450 meters squared. Now, using that same mathematical process, finding the area of the parallelogram.
40 times 18.
So the biggest trick there is to use the correct height, 18. So the area of a parallelogram is just base times height.
Did you add them together?
Add those two numbers together to get the area of the composite figure. 1170.
Yeah.
711. All right, I want to get to one last shape that is the true. Oh, never mind. I gotta fix this real quick because it's really bothering me. Okay, what about this guy?
That guy.
This one's tough. So what would you normally do? So if you tried to do 1/2 base times height, how long is this piece?
Not 14 inches.
You don't know. How long is this piece? You don't know. So what are your options now?
Right.
Wait, what if you find
Okay, so you could find the area of a square.
Oh, you could do that.
Because you know that this is a square that looks like this. So the area of the square is 14 times 14, or 196 feet squared. Now what?
You find the area of that triangle that's separating the two triangles.
You can find the area of this triangle
Oh, because it's 15.
because it is 14 units for the base and it is 14 units for the height. It's enough. This is the trickiest part of geometry. Do you see it or do you not? So 14 times 14 divided by 2 is 86. So if you take this number and you subtract the area of the red triangle, you're left with, it's not 86, it's 83. If you take this number and subtract the area of this number, you get it's 93.
Yeah.
Yeah, I was about to say. No.
It's
Yeah, 90.
The area of the red triangle is 98. So then when you take the area of the square and you subtract the area of the red triangle, you get 98. So the area of the square is 196. The area of the upside down red triangle is 98. You subtract those two areas, you get the area of the two white triangles combined are 98. That seems like a really awkward coincidence. That the area of the red triangle and the area of both white triangles are both 98.
So let's find the area of each figure. So would we have to find each individual triangle after that?
It would just said find the area of these two figures. So watch this.
oh,
How tall is it?
14.
How big is the base? So that you can just do base times height divided by 2 to find the area of that one triangle.
We can't do that on our paper.
Sucks for you. You can do it in your mind.
That's
Yeah, you can do that on your paper. You ready?
measure it out on your pencil or whatever.
You just do this. I'm gonna add this piece over here and add this piece right here. Now I know that this whole piece is 14, and I know that this piece is 14.
So you can just move your shapes around?
Yeah, it's geometry. It's all shapes. Bro, Callie, what?
Yeah, it says find the area of each figure. So would that be both the triangle, or does it? It's just 98.
The answer is 98. It doesn't want you to do it individually.
It doesn't.
There's not enough information to do that. It's just find the area of.
Okay, and both of
So
them
technically,
together.
after you
Both of them together.
wait, I
I'm past it. Okay,
wait, oh, I have a shoe. Oh, I have a question.
go ahead.
No, never mind. It's
No,
good.
no,
We're good.
that's good.
Well, cause like, so now how you found the area of the square, and you took away the area of that big triangle that goes in there, but it's there.
Yeah.
Would the answer be? Cause like it was 98.
Yeah.
So technically, since you took the triangle away from the area of the square, it leaves only the two triangles. So wouldn't that technically be the answer? You wouldn't have to really move the triangle.
No, so it's just two different ways to do the same
Yeah.
problem. Because the area of a triangle is half the area of a square.
Oh.
1/2 of base times height. It's half the area. Okay. What about this one, right? This is where geometry becomes fun because you can kind of create whatever shape you want and find the area of whatever shape you create. Yes, sir.
Draw the line down from where 5 is.
So that would be an intelligent way to start. You could find the area of this shape. 5 times 16.
And then you take.
Then you have to find the area of this triangle right here.
So you take 6.5 away from 16 to find the height of the triangle.
So from here to here is 9.5.
And then you have to take 5 away from 14. 9. And then you do the baseline height of 1.5. You get a 6.
Okay, wait. Whoa. You lost me.
You lost.
Just make a new triangle. Or Make your own shapes.
Okay. Two things just happened. We drew our own line right here. So I'm able to find the area of this rectangle by doing base times height. That's where I got that number. Then I have to find the height of my triangle. I need to know how long this line is. Well, if the whole piece is 16 and I take away 6.5, it'll land me this geometric length right here, aka 9.5. Then the same thing goes. If this whole length is 14 and I take away 5 units, it leaves me with 9. So then you have to do 1/2 the base times the height. If you do 1/2 base times height there, you get 85.5, and you cut that in half, you get 47.75. 1/2 times base times height. 42.75.
Human calculator.
All day, every day. So you have to add these two areas together, the red area and the blue area, to find the area of the composite figure, which would be 112.7. 122. All right, last one here. This one's important.
Thank you.
This one's tough, right? It says the shape has a ratio of lengths of 5:3, and the area of the shape is 135 millimeter squares. What is A and what is B? So we'll call this shape a triangle, because you have to know what shape it is. So a triangle has a ratio of lengths of 5:3, and the area of the triangle is 135 millimeters squared. What is B and what is H? So if the base is 5, the height is 3. If the base is 10, the height is 6. If the base is 20, the height is 12. Okay, so they have a 5:3 relationship.
Oh, okay.
That means you have to find
You have to find one that
the ones that multiply it.
Guessing and checking will not work here because I tried that and it took me 30 minutes. So here's what I stumbled upon. If I know that the base and the height have a relationship of 5:3, you can solve the area is equal to 1/2 base times height. Right? The area of the shape is 135. And that's equal to 1/2 the base times the height. No matter what base or what height I use, they will have a 5:3 relationship, 5x and 3x. This is the winning equation here. So it's 1/2 5 times 3, but you add x's to the lengths. So 5x times 3x is 15x squared. You can cut that in half if you want to. How do you get rid of the 7.5?
You square root.
It's like 18. So right now I know that x squared equals 18. So I have to square root both sides. Would you ever guess that number? Okay, cool, right? That's just x.
You have to find that.
You still have to solve for b and h. So solve for b. Solve for h. And if you calculated 1/2 times the base times the height, what answer should you be getting?
130.
35. Oh, what happened? Freak you out? You wanna try an easier one? Let's go. Parallelogram. They have a 1-to-2 relationship, and the area is 50.
Oh.
So what is the formula to solve for area?
A equals 1 base. Oh, we're looking for parallelogram.
Parallelogram. So if they have a 1-to-2 relationship, the area is equal to 1 base times 2 heights. Doesn't really matter. 2 x's. It is a 1-to-2 relationship. 1x times 2x. Well, the area is 50. What is 1x times 2x's?
2x squared.
Cut both sides in half.
5 equals x squared.
The square root of 25?
5.
5. One times 5 is 5. 2 times 5 is 10. Boom. 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 Cool? That's going to be the hardest part, right? That is on your quiz. That is on your quiz. So, realizing if you can get to this part, then it's your job to solve it the rest of the way. So, your assignment today, 523. One through 20. Skip number 11.
Can I do this on the back of my notes real quick?
This is just a practice assignment. On Monday, I'll see you guys Monday, Tuesday. I'll probably not see you because you'll either be testing or you'll be with me in the portable. I want to give you guys the last 15 minutes just to kind of peruse through the book and try some of those problems. Guys, it's purely just practice. Just practice. So do enough to where you have a chance at the quiz, but don't kill yourself. Next week, probably. I'll double check that.
A book? Like a book or like a book?
You hide your geometry book under your desk or something?
Oh, that's the answer to you. The quiz is next Friday.
Does it look straight up?
I think. Oh, I'm still recording.
Oh, no.